Good morning from Mission Control in Houston and the International Space Station Flight Control Room. Yesterday, it was a spacewalk by 2 Roscosmos cosmonauts. Today, a space freighter arrives at the International Space Station, the brand new HTV X-1, Japan Aerospace Exploration Agency's new cargo ship that is on final approach for a capture robotically by JAXA astronaut Kimiya Yui, backed up by NASA's Zena Cardman using the station's robotic arm. Capture scheduled about 2 hours and 44 minutes from now.
On the main white navigation light.
Copy. Green you see, but not the white.
You're hearing the voice of NASA's Zena Cardman, who, along with Kimiya Yui of the Japan Aerospace Exploration Agency, will be in the cupola at a robotics workstation. Yui will be primed for extending the Canadarm2 robotic arm once the HTV X-1 arrives about 30 feet away from the station. Yui will reach out and grapple a grapple fixture on the HTV X-1 to complete its 3.5-day journey since its launch from the Tanegashima Space Center in southern Japan.
Houston Station for HTVX. So far, we only have visual on the green light.
The journey of HTV X-1 began on Saturday night, U.S. time, Sunday morning, Japan time, with an on-time liftoff from the Yoshinobu Launch Complex at the Tanegashima Space Center in southern Japan. Atop an H-3 rocket, the HTV X-1 lifted off and some 14 minutes later separated from the second stage of the H-3 rocket to begin a pre-programmed arrival for a rendezvous at the International Space Station, which is in its terminal phase as we speak. The H-3 rocket performed perfectly both stages, delivering the HTV X-1 cargo ship on time and its preliminary orbit, after which a series of rendezvous maneuvers increased the altitude of the HTV X-1 incrementally to match that of the International Space Station for the final phase of the rendezvous, which is well underway. Just a couple of minutes ago, the HTV X-1 arrived along what is called the R-bar, the radial vector, directly underneath the International Space Station, currently at a distance of about 640 meters away, approaching at a rate of about 1 meter per second.
Copy, navigating via LiDAR and R-bar approach.
And from external cameras on the International Space Station, our first view of the HTV X-1 along the R-bar, that is basically an imaginary line that's drawn between the station and the Earth. There'll be several hold points for the HTV X-1 as it completes what are called near-field on-orbit systems demonstrations.
Great news. As soon as the sun set, the red and white lights became very visible. We have good visual on all 3 navigation lights.
Copy all. Thank you for that report.
You'll be hearing the voices of Zena Cardman and Kimiya Yui, again, operating from a robotics workstation in the cupola of the International Space Station. On console at this hour is the lead flight director for HTV X-1, Fiona Antkowiak. Sitting to her left at the bottom of your screen is Flight Director Elias Mirmo. The spacecraft communicator at the top of your screen is Japan Aerospace Exploration Agency astronaut Aki Hoshide, who himself used the station's robotic arm to capture HTV-3, one of the legacy cargo ships that delivered 9 different cargo runs to the station between 2009 and 2020. Hoshide captured HTV-3 using the Canadarm2 robotic arm on August 27, 2012, as a member of Expedition 32. The International Space Station is currently traveling from southwest to northeast, just off the west coast of Australia, in an orbit inclined 51.6 degrees to either side of the equator. Now that the HTVX has arrived directly below the station, There'll be several hold points for various periods of time where these demonstration activities will take place. The HTV-X1 will stop at a distance of 250 meters, then 30 meters, and then at a capture point just about 10 meters away from the station, at which point UE will extend the Canadarm2 robotic arm to grapple onto HTV-X1. Once that occurs, the robotic chores will be handed off to the robotics officer here in Mission Control in Houston, who will slowly but surely maneuver HTV-X1 directly underneath the nadir or Earth-facing common berthing mechanism on the Harmony module of the International Space Station, carefully moving the HTV-X1 to its installation point on that common berthing mechanism for it to be bolted into place, basically hard-mated, for its 3-month stay on board the International Outpost. So far, the LiDAR sensors on the HTV-X1 have performed normally and up to speed. The other near-field on-orbit demonstrations that lie ahead will be a hold performance demonstration at the 250-meter hold point, basically to monitor the HTV-X's stability close into the International Space Station and to confirm that it's within the position and velocity limits set during the approach by the Japan Aerospace Exploration Agency. There will also be a retreat, or basically an abort performance demonstration, where the crew itself, UE and Cardman, will send retreat commands to HTV-X to enable it to back away slightly to ensure that it could have that capability should a systems problem occur close into the station. Once that demonstration has been completed, HTV-X will resume its approach inside the keep-out sphere and move to its final capture point some 10 meters away from the International Space Station. HTV-X1 is carrying about 4.4 tons of supplies and experiments for the Expedition 73 crew aboard the International Space Station. The plan calls for the HTV-X1 to arrive at the station for a capture some 2.5 hours from now. The actual capture time is not it's not written in stone. We could arrive earlier for an earlier capture, but nonetheless, the crew on board the station will not open the hatch and begin to unload the cargo on HTV-X1 until tomorrow. And from external cameras on the station, you can see some of the strobe lights on the outside of the HTV-X1. The HTV-X1, about 400 meters now away from the International Space Station, will arrive at a distance for its first hold point of 250 meters just a few minutes from now. This will be about a 30-minute hold point. The first of these hold points at 250 meters will be designed to conduct the LiDAR sensor tests and a hold demonstration capability, which will be assessed by the Japan Aerospace Exploration Agency engineers who are in the HTV flight control room in Tsukuba, Japan, as well as the flight control team here in Houston. Once the HTV-X1 is bolted into place on the Earth-facing side of the Harmony module of the International Space Station, that will leave just one open port on the station. That final port, the Rosviet module, on the Earth-facing side of the Russian segment of the station, will be occupied on Thanksgiving Day when the Soyuz MS-28 spacecraft arrives with the next trio of residents for the station. That will include NASA's Chris Williams. At that point on Thanksgiving Day, every single port that is used for either an automated docking or an installation on a common berthing mechanism will be occupied on the International Space Station. And the arrival of HTV-X1 coming just days before a significant anniversary. On Sunday, the station will mark the 25th anniversary of a permanent human occupancy that began with the arrival of Expedition 1, Bill Shepard, Yuri Gudzenko, and Sergei Krikalev on November 2nd, 2000. HTV-X1 has slowed its approach as planned, coming up the R-bar. Again, the R-bar is the radial vector. If you basically draw a cross-haired target, the middle of that target would be the station, and at the 6 o'clock position is the R-bar, or the radial vector, the imaginary line drawn between the station and the Earth. The HTV-X1 is inchworming its way up the radial vector, currently 300 meters away from the station, closing at a rate of 0.3 of a meter per second. We're about 25 minutes away from coming into an orbital sunrise, which should provide our first good views of the HTV-X1. And for the first time, looking at a vehicle from the Japan Aerospace Exploration Agency that has deployed solar arrays. The legacy HTV cargo craft had body-mounted solar cells for its electrical production. The twin solar paddles, as JAXA calls them, were deployed a few minutes after the HTV-X1 arrived on its preliminary orbit on Saturday evening. The systems on the HTV-X1 have performed well during all of its demonstration capability, arriving on course and on time for its expected capture some 2.5 hours from now. The HTV-X1 is using its navigational data from LiDAR sensors, which are doing well in processing data regarding the range to the station and its rate of closure. The LiDAR sensor demonstration test that is currently underway basically compares two separate LiDAR units that are used for navigational updates to the computers on board the HTV-X1, cross-comparing all of that data to ensure that the approach of the HTV is well within expected error limits. We're about 13 minutes away from arriving at the first hold point on the critical phase of this final rendezvous. That would be the 250-meter mark. Once HTV-X arrives at 250 meters, the crew on board and flight controllers, both here in Houston and in the HTV control room in Tsukuba, Japan, will be monitoring the hold performance, basically the ability of HTV-X to maintain a stable orientation without any rate of closure, and to confirm that that's within position and velocity limits. And this view, coming to us courtesy of the Japan Aerospace Exploration Agency, is of the HTV flight control room in Tsukuba, Japan. This is a separate room from the ISS flight control room for JAXA that is operated 24 hours a day, 7 days a week in support of expedition operations. These flight controllers are specific to HTV operations. They are on their consoles, monitoring all of the data that's coming in from HTV-X1 and communicating directly on the loops with the flight control team here in Houston. We should be arriving at this 250-meter hold point just a few minutes from now to allow the LiDAR and hold demonstrations to begin. A poll will be taken for a go, no-go to continue on and depart the 250-meter mark, as well as the approach and retreat demonstrations that will take place a bit later in HTV-X's climb up the R-bar towards its grapple point, which will be some 2 hours and 20 minutes or so from now. This is the view that Kimmie Yui of JAXA and NASA's Zena Cardman are currently seeing from their robotic workstation in the cupola, with all of the overlaid data that shows the corridor, if you will, that the HTV-X1 is climbing up the radial vector to approach the station for the final phase of its 3.5-day journey for grapple and installation to the Earth-facing port of the Harmony module of the International Outpost. The International Space Station is currently flying 260 miles above the Earth in tandem with the HTV-X1, moving from southwest to northeast in an orbit inclined 51.6 degrees to either side of the equator. And flight controllers now confirm that we have reached the 250-meter mark between HTV-X.
HTV-X confirmed 250-meter hold for step 2 in 1.102. And be advised, if you're looking at the rendezvous details page, if you look at the secondary range, that is under LiDAR 2, you can disregard that.
We can disregard the range under LiDAR 2 on the rendezvous details page, which we are looking at, but we see on our monitors our prior range is 240. We've got our good 250-meter hold. We have good lights on the HTV-X command panel, and prior range currently 240.27.
Here's some copies all. Thank you.
And stand by for our first Block Bravo calls.
Stand by.
NASA's Zena Cardman reporting back to Aki Hoshide, the Japan Aerospace Exploration Agency astronaut, the veteran astronaut who is serving as spacecraft communicator today here in Mission Control in Houston. So HTV-X1 has reached its first hold point at 250 meters. This will be about a 30-minute period to enable a demonstration of the HTV-X's stability and its velocity limits before permission is given for it to resume approach to the next hold point, which will be at 30 meters. We're in a brief loss of signal from the International Space Station for our downlink TV capability from external cameras. We'll be getting that back shortly as we pass within range of the next set of tracking and data relay satellites.
Houston Station for Block Bravo.
Go for Bravo.
Looking at monitor 3, this is